Hello everyone, and welcome back to the Kohi Game Engine series. Today we're going to kick off a discussion and implementation of lighting. So before we jump into the video, I'd like to thank a few special people. We have the partners of the channel. Those are the highest tier of support through Patreon or YouTube memberships. And those partners are Caden, Eearslya, Joel, Kyla, and Wensheng. Also supporting the channel are all these other fine people on the screen. Thank you all very much for your support. It is greatly appreciated. If you'd like to support the channel and support my work, feel free to have a look at the YouTube membership, or if you prefer Patreon, you can check out patreon.com/TravisVroman. Alright, so lighting. One of the most important features in a renderer for a game engine, of course, is lighting. And we are going to start an implementation of a very basic lighting model to start off, just to sort of get our feet wet and start to grasp some of the concepts. So the way that this is going to work is I'm going to explain a lot of the higher level concepts and the code that sort of goes along with that. And we're just going to build on top of the lighting system probably for the next few videos or so. So the very first thing that we're going to do is we are going to start with directional lighting. That's going to be the first type of lighting that we actually introduce. So I've actually got GIMP here open. Directional lighting is basically where you have a surface and then you have light from a different direction, some direction, that points towards the surface. And so basically the way that this works is all lighting in the world, the light hits all surfaces in the world at the same angle. So you may have multiple different surfaces at varying degrees. So you might have a surface that's sort of at this angle maybe, or maybe you have another surface that is straight up and down, something like that. And it doesn't matter what angle the surface is at, the light will go ahead and hit it from that same angle. So directional lighting is exactly how it sounds in terms of what it's called. And as a result of this, because it's sort of global and applied to the scene as a whole, you generally only have one directional light in a scene. And more often than not, directional lighting is used for your sunlight or your moonlight. It's generally used for the overall lighting, and then you can have individual little lights on top of that are maybe other types of lights. But when it comes to the primary lighting of a scene, especially outdoor scenes, directional lighting is usually the one you start with, so that's the one we're going to go with here. So our implementation of directional light is going to be somewhat simple, but there are a few other concepts that we're going to need to understand in order to actually proceed with it. So I'm going to clear these out real quick. And some of the things that we're going to need are, we're going to need a little bit more complex geometry. So what we're going to start with for now is just a cube, but eventually we're going to need to load in some geometry from a file such as OBJ format or something of that nature. So we are going to be doing that at some point soon, but for now we're going to start off with a cube. We need a little bit more vertex information. We'll come back to that in just a minute. We're going to need another uniform. We are going to need a definition of a light, so we've already kind of defined that, at least conceptually, with our directional light. We're going to need some small material updates, and then a couple of tweaks and fixes in the engine of things that just need to be changed that I've noticed. So before we can actually jump into lighting, we need to understand one of the primary requirements of any lighting, which is the concept of a normal. And a normal is a directional vector, specifically, that is typically orthogonal to a face of geometry. So what do I mean when I say orthogonal? Well, if we're looking at sort of the side of this geometry here, and this is the top face, then your normal vector would come straight off of it, like this. Okay, so this red line is your normal. Excuse the crappy drawing here, but I think you guys get the point. So your normal basically defines what the front face of the geometry is, and you've heard me talk about front faces and back faces before. The normal is one of the things that you can use to define that. Now, obviously, there are other things that define that as well, such as vertex winding, which is the direction of your vertices in space. So basically the direction of your vertices clockwise or counterclockwise. And that can be used to determine front and back faces. But when it comes to lighting, we need to actually use the normal. So if we had something that was a little bit more complex, like let's say that we have maybe a shape that looks something like this. Just to give you guys an idea of what the normal might look like. This face is normal, goes off this way. This face is normal, goes off something like that. And this face is normal, goes off something like that. And if we also consider that we have back faces to our geometry, such as something like this, and it's normal, goes off in a direction like this, then what we're left with is surfaces that can be lit and surfaces that are not going to be lit. So in the example of our directional light, we'll switch back to our orangish color here. If we're saying that all of our light goes in the same direction, then this surface here will pretty much receive full light, whereas these side surfaces won't receive quite as much because they're not being hit at the same angle, right? So they'll be a little bit darker because they're not getting the direct light, whereas this back face doesn't receive any light whatsoever, so it remains black. And then we also have the concept of ambient light, which is sort of the default lighting in the scene. Now, ambient light can actually be a pretty complicated topic. I'm not going to jump into all of the complexities, at least right now, of light ambience and bouncing and reflection and things like that. We're just going to keep this simple for right now and say that ambient is sort of the default lighting of the scene. So if you think about a nighttime scene, when the moon is out, the moon doesn't necessarily reflect off of every surface, but you'll notice that nothing is completely black. Typically speaking, everything will be a very dark shade of gray or a very dark shade of sort of a bluish color. And that is what we're talking about the ambient color. It'll be the ambient color that is applied to non-lit surfaces. So if we talk about ambient color in this context, well, we might have something that's very dark blue, typically kind of desaturated for this background color, right? And that might be a little bit hard to make out here. It's not really important, but just kind of understand that concept as a whole. So this is a very rudimentary breakdown of this and what we're going to be building out and supporting. So our directional light is the first step of that, and that is what we are going to be adding information. So as I mentioned before, we need a concept of the normal, and then we'll also need this concept of the ambient light. And to do this, we're going to add this into a couple of different places within our material system. So before we jump into the lighting, I want to make a couple of changes of things that really need to be done to facilitate us being able to visualize this a little bit better. First off, we're going to get rid of this this huge image that's sort of blocking our way here because we're not going to be able to see the scene. And we want to replace this plane with something that's a little bit more interesting to look at. So let's go ahead and change this to something a little bit better. I have gone ahead in Assets and added a new image here to be used in place of that gigantic image that's just going to be up there in the upper corner. So in Application C, we want to come here to where we are generating the test UI geometry and change it up a little bit. So right now it's just generating a square using this F value. We actually don't want to do that anymore. We actually want a non-square shape. So I'm going to replace F with width and height. And then we can come down here and set all of the position Y's to height and the position X to width. And we have another height here and another width here. Okay. And then we will come into our material definition. And instead of orange lines 512, we're just going to use Kohi. Okay, so let's build and run that. All right, and that's a little bit better. Now we don't have that gigantic shape in our way. And you can see that it does blend here with the background just fine. So it's not really blocking anything anymore, but it lets us know that our UI layer is working. Okay, so the next thing that we should probably do is we should probably go ahead and generate our geometry, because without that, there's not really too much that we can do. However, I think before we generate our geometry, I actually want to go ahead and update the math type real quick. So I'm going to open up math types and go all the way to the bottom here. And we're going to modify this because we actually need to add some information to our vertex 3D. Now remember, I did say that these were going to be changing and that these two would diverge quite a little bit more than just in the vector 2 versus vector 3 position. Now is the time where that starts to happen. So as we mentioned before, we are going to need a normal for each individual vertex. And that normal is represented by a vector 3 because it is a directional vector, as I mentioned before. So we're going to add our normal here as the second component of our vertex 3D. And this is just so that everything here lines up nicely. So we have a vector 3, a vector 3, and a vector 2. And so this is a multiple of 8, and it just lines up a little bit nicer this way. So this is the way that I'm going to be structuring this. This has to be aligned the same way in the shader configuration as well to actually work properly. So you always want position, normal, texture coordinate. Okay, so the next change that we're going to make is to the geometry system. And if you recall, we have this geometry system generate plane config. We are actually going to add a new method right below that. And technically we need to make some updates to this too, but I'm not really going to worry about that for right now. We're going to add in a new method to generate a cube. And this is going to be a really straightforward, simple cube. Because we don't need a lot of fanciness or adjustability with this. This is only a temporary shape that we're going to use for testing purposes. Eventually, we want to be loading geometry the proper way. So for now, I'm just going to paste in the definition of this function and have a look at it. So similar to the way the other function works, this returns a geometry config. And the method is called geometry system generate cube config. And it takes in a width, a height, a depth, tile X and tile Y for UV coordinates, the name of the mesh itself, and then also the name of the material that it would use. We do some sanity checking here. We set up our arrays for our indices and vertices, just like before. Here we actually generate the cube based on half width, height, and depth. That way the cube has the origin of itself right in the middle, which is exactly what we want. So that way if we rotate it, it rotates based on the middle and not the upper left or something. And then we go through here and we add position information, texture coordinates, and normals for each face. So I've got comments in here as to which face is which. So we've got our front, back, left, right, top, and bottom. And basically all we do is we index the array, going by what face we're on times 4, and then plus 0, 1, 2, or 3, depending on what actual vertex we're actually looking at. And so this is the position for the first vertex. This is the position for the second vertex, the third, and the fourth, and so on. This is the texture coordinate for the first, texture coordinate for the second. This is the normal, this is the normal for the first, and the normal for the second, and so forth. And that pattern just continues all the way down through here using mins and maxes as we did before. So you guys have already seen this. If you're interested in more detail than that, rather, you can have a look at the code. But the important bit to add here is that we are adding the normal information to this. So the normal for the front face is 1.0 on the z-axis, which means it's pointing straight at the camera. The back face is negative 1.0, which means it's pointing away from the camera. Our left points to negative 1.0 on the x-axis, which is to the left. Our right points on the positive 1.0, so that's to the right. The bottom is negative y, So -1 on the y-axis, so it will point down, and then the top, of course, points up with a positive y value. So this is all there is to that, and then we have the index generation here. We copy over the string for the config name and the material name, and then we go ahead and return the config. Okay, so that is all there is to that method. It's not really complex, it's just kind of a lot of code. Obviously, since we have done the C file, we need to update the H file so that we have something to call. I will fill this out with comments afterwards, but this is basically the signature for that. So that is all there is to the geometry generation. There's not a whole heck of a lot to it. Thankfully, it's actually pretty straightforward. So if you guys, again, are interested in the details of that, feel free to have a look through the code. Okay, so the next thing I actually want to change is I need to fix a bug that I realized is in the renderer. So we want the front end, and right around where we are applying the local for the UI, we are actually applying the geometries index I model instead of the UI geometries model. So we just need to fix that, or otherwise when we go to update the model matrix of the mesh, it's actually going to update the model matrix for both of these visually at least, and that's not correct. So we need to go ahead and fix that bug. So if we go back to our application and we look for our gconfig, we are going to replace the plane generation with our new cube configuration generation. So we're just going to generate a 10 by 10 by 10 cube with a tiling of 1. The name is still going to be test cube, and the test material will still be used. So let's go ahead and build this and just have a quick look at it. Whoa, that is decidedly not right, and I can tell you why. So I should take this time to point out that occasionally in development you are going to get weird stuff that looks like this, and this is usually a data alignment problem. So I'll give you guys a couple of seconds to try and figure out why this happened. The reason this happened is because we actually changed the vertex input, right? We changed the vertex 3D structure, but we didn't actually update the shader to accommodate that. So we need to actually update that so that the data aligns properly. Otherwise, you're going to get a mess like this because it's interpreting the data different than how you think it's actually going to interpret it. So let's go ahead and fix that. Now, thankfully, because of the changes that we have made in our system, the changes to this are actually going to be mostly configuration based. So the first thing we're going to want to touch is the shader built-in material shader config. Right here in our attributes, we are going to want to add a new one in the same position as we did in the vector 3D. So we'll have our position, normal, texture coordinate, vector 3, vector 3, vector 2. So that's that. And the second place we're going to want to change this is in our vertex shader, because our vertex shader is also just looking at these two things. So we actually need to change our vertex shader to accept normals as well. And that means that we are going to change text coord to position, location 2 rather, and put normal in location 1. All right, so now we should be able to run our post build and build for good measure and execute. And now it looks like we have just a square here, but if we actually move our camera to the side and up and around, we can see that we have our cube generated successfully. And let's just take a look at the bottom face real quick, right? So we have our cube geometry working as expected. Not too exciting, but at least it's something. So the next thing I want to do is make this a little bit easier to visualize that our texture coordinates are correct, right? Because we just put in a whole bunch of changes to our geometry generation logic. So we need to actually make sure that our textures are aligned and facing the way that we actually want them to be facing. So I'm going to make one more small change to the test material this time. And I'm going to start off our diffuse map. Instead of paving, I'm going to use the orange lines 512. And I'm going to go ahead and run. And now we can see that our 512 by 512 is facing the correct direction. And if we just have a quick look here around all sides of the cube, we can see that it is all mapped out correctly. We don't have any weird texture distortion or anything like that. And the numbers are readable, nothing is backwards. So we are all good to go on that front. So it's just a nice little test there. So the next thing that I want to take into consideration is we need our ambient color, right? Because before we can actually light stuff, we need to have a sort of darker ambient color for things that aren't lit. So our ambient color is going to be the next thing that we add. And to add that, the first step is going to be to go to our shader config. And this time we are going to add a new uniform, because this isn't going to be part of the vertex information. That doesn't really make sense. This is something that is global level. If that gives you a hint as to where this is going to go, you'd be right in guessing that it goes here as a global uniform. So it's going to be a vector 4 ambient color, and that's just going to go right in here. So that is it for the shader config. Thankfully, our changes there are pretty straightforward. This does mean, though, that there are a couple of changes that we're going to need to make. So the first set of changes that we're going to need to make is to the material system. So let's go back to the material system, and we'll go to the top here. And we need a new location for this. So as you may have guessed, we're going to call that ambient color. It's just a U16. Again, this is just a simple, lightweight index of the uniform's location. So right down here around line 200 or so, where we're adding, where we're getting all of our uniforms, we need to go ahead and right below view, obtain the location of our ambient color just by looking that up by name. This means that since we have that, we are actually going to have to go to our apply global, and we actually need to add in a new parameter for this. So that is going to be called, as you may have guessed, ambient color, and it's going to take a pointer to a vector 4. And of course, this is only going to be applicable to our material shader. So our UI shader is actually just going to completely ignore the value that's passed in here. We don't need it. And I'll show you how we go ahead and handle that on the front end in a minute. But here we just apply by index the ambient color to the index of the ambient colors uniform. One more thing while I'm in this file that I want to fix is right down here in create default material. We did not actually assign a shader ID to the default material. And we are actually using the material shader for that right here, but we didn't actually wind up hooking up the ID. So that's going to cause problems in the future whenever we need to use that. So this is also just another quick little bug fix just to make sure that the materials shader ID is hooked up correctly. Okay, so that is it for the material system, at least in the C file. Obviously, since we updated the signature in the C file, we will also need to update the signature in the header file. So we'll just add a new parameter there for ambient color, and we'll go ahead and add as well a comment for that. And now we can go ahead and set that. Okay, so where does this ambient color come from? This is part of our sort of global state for right now. So as you may have seen, our renderer front end is now bleating because it has the expectation of extra parameters being passed to the global update. So we're actually going to go up here and handle our material system apply globals first. So this is actually expecting another property here, but we don't have anything to pass it. So before we can pass something here, we actually need to fix that first. So if we go to the top of the file, right here in our renderer system state is actually where we're going to store the ambient color for now. Now this may wind up changing, but for now it just kind of makes sense for it to be here. It goes with the view and the projection that are already here, sort of in that global state already. So we just have our ambient color here to go with those. And we also need some sort of default from this. And obviously you would not want to define this default in the renderer, you would generally want that to come from the scene, but we don't have a scene yet. So what we're going to do for now is we are just going to default that to a value in the renderer and put a to-do that we need to address that in the near future. So we're going to set the state pointer ambient color to a dark gray color here, which is basically the RGBA. So 0.25, 0.25, 0.25, and the RGB, and then it's just a solid 1.0 for the alpha. And that is going to be the value that we actually pass in to the apply global. So if we head back down to where we have our error, we can just now add the state pointer ambient color, or the address of that rather, and that fixes that bug. Now, if we go a little bit further down, we have our material system apply global for our UI shader, but you recall we actually don't recognize that. We don't use it. We don't need it. So we can actually just safely pass 0 here because nothing is actually being looked at for that anyways. Okay, so that is it for the front end. Let's go ahead and build and run. Okay, and we don't see any visual update. This was purely just to make sure that we haven't broken anything. Okay, so now we have this new uniform, and it's configured in our shader, but our shader itself doesn't actually have any code to reference it. So that is going to be the next piece of the equation here. So there are a couple of changes that we're going to need to make in our shaders. The first place we're going to start is in the vertex shader. And the first change we're going to make is we've already added our normal here. In our global uniform object, we are going to add in ambient color. So now we have our projection, our view, and our ambient color. And note that the order of these is actually important as well. It needs to match what is in the shader config. So we have our projection, view, ambient color, and then if we go back here, we have projection, view, ambient color. That is important. Okay, so the next thing we're going to need is our DTO. We're actually going to start using a little bit more. So here we actually have just a text coordinate that we're passing over, and we actually need to pass our ambient over for right now. So we need to put it out here, and then we need to copy it over just by doing as we did for the texture coordinate. So setting the out DTO.ambient equals global UBO equals global UBO ambient color. Okay, and then on the other side in the fragment shader, in DTO, we need to add it to the same location, right? So again, these have to line up with these. So always make sure that all of your data lines up and is in the same order, or otherwise things are not going to be interpreted the way you think they will be. And the next thing that we're going to do is we're going to actually add another thing to our vertex. Okay, so we have our ambient color, but we also have the normal that we're now passing in, right? And we're just sort of taking this in here and not really doing anything with it. Well, we need to actually pass that over too, because we're going to do all of our lighting calculations in our fragment shader. So we actually need to pass through the normal in our DTO as well. So I'll go ahead and add that in both locations. Oops. So that they align. And so we'll go here, we'll go ahead here and just add that as well. And all we're doing for now is we're just copying that over. Okay, so that is the vertex, and then on the fragment shader, we are going to make use of both of those things. So the fragment shader actually requires a couple of things. The first thing it requires a concept of is a directional light. And by default, a directional light provides two things. It provides a direction the light is pointing to, and it provides a color of the light itself. So we are going to actually set up a new structure. We'll put it right here below the object UBO. And we're going to call this directional light. And it's going to give us a vector 3 for direction and a vector 4 for color. And for right now, we are actually not going to pass this through because this implementation is going to be changing a little bit over time. So we are actually going to create one directly in the shader and just use it instead for right now. We're going to hard code this. And this is a common thing that you're doing when you're adding new features and you're trying to test stuff out quickly. Instead of going through all those layers to add everything, sometimes you can take a shortcut like this while you're playing around with different values and stuff to save yourself a little bit of time in testing new features. So that's what we're going to do here. So the type is directional underscore light, which is our structure here, and then we're just going to call this dir underscore light. And we're going to set its values. So here is the direction, and you can think of this from the default camera position coming from the upper right corner of the screen and then from behind us. So it's pointing down towards the center, right? So we have that, and then we have the light's color itself, which is a very light gray, almost white. Generally, light is not completely fully 1.0 white across the board. It's generally some mixture. So we're going with 0.8 here, just because we don't want stuff that's too extreme or too bright. So here is our directional light. Obviously, I have a to-do in here to feed that in from the CPU and do it properly using uniforms. But for now, this will suffice. And the next thing that we're going to do is we're going to split up our lighting calculations into different functions. So we're going to have a function per lighting calculation. So the first one we're going to add is something called calculate directional light. And we're going to prototype that here, and then we're going to define it below the main function. So calculate directional light takes in a directional light, and then takes in a normal, and returns a vector 4, which is a color. And the definition of that looks something like this. So there's a couple of things going on here. The first is what we're going to call the diffuse factor. So this takes the dot product of the normal that we have in the scene. This is the normal of the face that we're currently looking at, and runs the dot product against the negative light direction. So it basically takes the direction of the normal and compares it to the direction the light is coming from. And based on that, it will either be lit or unlit, or some variation in between. So if it winds up being a back face that's facing away from the direction of the light, it won't be lit at all. Whereas if it is at least somewhat facing the light, it will be lit on a scale depending on the like direction with the light. So if it's exactly the same direction as the opposite of the light direction, in other words, it's facing the light directly, it will be the brightest lit. Otherwise, it will dull out from there until it becomes a back face where it won't receive light at all. So that is what this function here is doing. It looks pretty complicated, but it's actually really not. And the max on that dot product here is to just say anything that's negative, just zero it out. Because we don't actually want a negative value on this. We want to zero it out, meaning no lighting. The next thing we do is we sample the diffuse texture, right? So we already have this guy up here. We're already doing this here, but this is going to be changing. We go ahead and sample that, and then we apply the ambient light to that. So we basically take we get the ambient light value as if it's unlit by taking the ambient color and multiplying it by the diffuse color. And then we take the alpha of the diffuse map. And that is to determine what is see-through and what isn't see-through. Because we don't necessarily want to provide transparency on any other map that we use down the road. So if you have a transparent texture, like leaves or something like that, you don't want the spaces in between the leaves to be lit. You want no lighting to be applied to that. So that's why that's taking the alpha from the diffuse sampler and not from the lighting calculation itself. So we calculate by adding in the ambient, and then we calculate the diffuse by adding in the diffuse factor that we calculated up here. And then what we do is we basically take the ambient color value and the diffuse color value, which are just flat values at this point, and we combine them with the diffuse sampler. So we do that once for the diffuse and once for the ambient. And that is why we save this off once, because we don't actually want to sample this texture more than once. We want to grab the texture once and hold on to it and then reuse it for both of these. Okay, so we take these two colors then and add them together and return it, and that is our result. So what that means is our out color up here actually changes because we don't do this anymore. We simply call calculate directional light. And that will give us our final light color. All right, let's go ahead and post build, and let's just build the project just for good measure. Go ahead and run. Okay, and we can see it looks slightly different, like it's not lit quite as much, and that's because our directional light is 0.8. So it does look a little bit darker. You're not going crazy. So if we go around here to this side, all three of these sides are lit up. So that's great. But if we go around to the other side, we'll note that these are now shaded because they are pointing away from the direction that the light is actually coming from. So these two sides are shaded, and then the bottom is shaded as well with that ambient color. So this is how the basics of directional light work. Okay, so we have that up and running. One more thing that we want to cover is we don't necessarily want just a plain Jane sort of static scene just sitting there, right? Let's actually add something to this to make the cube spin. So I'm going to just search for test render. Here we go. So right now, as the model matrix, we're just using identity, which is just static, not very interesting at all. It's just there, it just sits there. So what I'm going to do is implement some rotation logic here. So we're going to have a static float, and this is just very temporary code, but we're going to have a static float called angle, and we're going to start that off at 0. And this static is sort of inline so that it remains the same during the course of the application. And so we'll just be updating this as we go. And on every frame, we are going to add 1.0 times the delta, which is the delta time, to that angle, right? So that's going to scale it by our frame rate. And then we're going to go ahead and create a quaternion rotation based on axis angle. So we're going to rotate on the y-axis to the current angle. And we're going to go ahead and normalize this. And then we're going to go ahead and set our test render.model to the result of quat2mat4, where we're going to pass in our rotation quaternion and receive back a rotation matrix. So let's go ahead and build that and see how that looks. Okay, looking good so far. Oh, wait a minute. This isn't right, is it? It looks good until you actually see these other two sides and you're like, wait a minute. I thought the light was over here, but now we're rotating this around and the light isn't actually changing. What the heck? So this is because we have actually missed a crucial important step. Back in the shader, we are just copying over the normal as is. This normal is in what's called object space, which means it's local to the current object or the matrix that we're rendering against right now. The light, however, is in world space, so it's global. And so what we need to do is we need to take the normal of the face from being object or local and convert it to being global, or what's known as world coordinates. And to do that, you simply multiply it by the model matrix that we pass in. And we can simplify this a little bit by converting it to a matrix 3, because the last row and column are not actually needed for this calculation. So we can take the matrix 3 of that and multiply it by the in normal, which is a vector 3, which is basically a 1 by 3 matrix, and get a 1 by 3 matrix as our new normal. And so if we do this and save, run our post build, and run again, we now see that our lighting is actually changing based on the angle. So our lighting is actually consistent. If we look over this way a little bit, we can see these faces darkening as they turn away from the light. And if we go over here on the other side, we can see these faces lightening up as they turn towards the light. And our top and our bottom still look as expected. So now we've taken that local normal of each one of these faces and converted it to world space. And that gives us our correct lighting calculation. Anyway, that is going to do it for this video. So thank you guys so much for watching. If you liked the video, please toss it a thumbs up. If you haven't already, consider subscribing. It helps me out a lot. And click the little bell icon there to get notifications as to when new videos in this or other series drops. And I will see you guys next time.